Hello everyone, in today's video we'll be covering from question number 31 to question number 43. That means the complete chemical properties of aldehydes and ketones. Now let's read what is question number 31. Question number 31 mein the compound has been given aldoxime and we have been asked to treat it with H2SO4 and the product has been asked what product will be formed. Now understand the reaction. So in this question H2SO4 is given, which will supply us H plus and it will protonate the alcohol's oxygen, form OH2 plus. The moment this OH2 plus will be formed, there will be some series of steps which will take place, which are called Beckmann rearrangement. What exactly is the Beckmann rearrangement? This is the acid catalyzed conversion of aldoxime or ketoximes to respective amides. So this is your oxime group. NOH group is called the oxime group. This oxime group is gonna convert into amide group. This rearrangement is called as Beckmann. It takes place in the presence of the catalyst like H2SO4, PCl5, PCl3, etc. Now what's happening exactly? This H2O plus will try to cleave its bond with nitrogen to get rid of the positive charge. At the same time, the group which is present on the anti position with respect to the OH2 plus will attack on the nitrogen. So basically alkyl shift or R minus shift is happening from this position to the nitrogen position, from the carbon position to the nitrogen position. So alkyl shift is what is happening. Why alkyl shift is happening? Because it is on the anti position. Any group which is present on the anti position will be shifting. If you don't know which group is present on the anti position and the compound has not been written in such a way that you can determine it also, so in that case we'll be using the migratory aptitude. Now CH3 will be shifted over here. It will shift as CH3 minus and ROH2 plus will be out because this would be developing delta positive charge as this bond would be cleaving. So R minus would attack over here, shifting the plus charge to the carbon. It is same as the carbocation shift. In simple words, you can also say it is something like the CH3 double bond N plus and lone pair. Though it's not forming plus though. It is simultaneous attack. If this will shift over here, plus charge will shift on the carbon. So it is very similar to the alkyl attack or 1,2 methyl attack or 1,2 methyl shift, 1,2 hydride shift. These kind of shifts happen in carbocation. This is not happening in carbocation. This is happening simultaneously as OH2 plus is going out. CH3 is attacking simultaneously, ultimately forming this carbon with a cation. Then we have water in the system which has got lost from the molecule earlier. That will attack back on this carbon, forming OH2 plus, ultimately leaving H plus and forming enol. So this, if you see, is a enol which can further tautomerize to form its respective ketone. This carbon is forming in a ketonic form. In general, if you see the total group, this total group is amide group. So conversion of ketoxime to amide is called Beckmann rearrangement. Now come to question number 32. Now in this benzaldehydes carbon, that is C double bond O, carbonyl carbon should have more delta positive charge than some species given in the compounds. Then only benzaldehyde will be more reactive towards the nucleophilic reactions as compared to that particular compound. So let's see. If I say HCHO, HC double bond OH, it doesn't have minus M plus M or any such thing. So its delta plus is quite high. CH3 C double bond OH, delta plus is reducing because of plus I over here. pH C double bond OPH, in this case plus M and plus M on both the sides. And if you see pH CHO with which we have to compare, there is only 1 plus M. So delta plus is less over here, lesser than CH3 CHO and HCHO, but at least more than PHCO. pH basically this benzophenone से ज़्यादा we have a delta plus over here. That is the reason why this has the more delta positive, hence will be more reactive towards the nucleophilic attack. Now come to question number 33. In question number 33 we have to form the product of the given compound. Now in given compound, if you see, we have been given an alcohol and also aldehydic group. Clearly this looks like the acetyl and hemiacetyl type of reaction where alcohol is reacting with CHO in the nucleophilic addition. Nucleophilic addition is gonna happen. H plus will first attack the oxygen of CHO, forming C double bond OH and H. At the same time, when the oxygen would be breaking its bond with the carbon. Same time, oxygen will attack on the carbon due to the electron deficiency on the carbon. and this kind of bond will be formed. So it is when carbon's oxygen has gotten a positive charge on itself, it will try to cleave its bond with carbon. At the same time, oxygen ka lone pair will attack on this carbon. So two attacks are happening simultaneously and eventually forming something like this. Okay, now this oxygen of alcohol has become protonated. Now it has become not protonated, it has got a plus charge now. So this plus charge, to get rid of this plus charge, it will kick away the H plus and will form this. So here we have an ether group and a alcohol group, which is not a complete acetal, this is hemiacetal. So this is a cyclic hemiacetal is what we are forming in this reaction. Now come to question number 34. The end product of the given reaction is, we have to find out the end product of this reaction. Now, first of all, chlorination is being done, and chlorination, that too one equivalent. So second degree carbon pe chlorination will happen easily. So you will do the reaction over here, you will get a chlorine over here. This is a simple halogenation reaction. After this nothing we are giving in the reaction mixture. The reaction mixture has nothing here apart from NaBH4. So NaBH4 and OH minus in the basic medium is basically going to do nothing but reduce your ketone to alcohol. So it should be this, your ketone is converting into respective alcohol, and then after this the intra SN is happening, where the oxygen's lone pair is going to attack onto the delta positive carbon over here with the chlorine, and when this happens, it will form a cyclic epoxy sort of thing over here by kicking out the chlorine as a leaving group. Then H plus will be out, overall HCl will be out, and this will be the product formed, which is your option number C. Now come to question number 35, which is pretty much same as what we have done in question number 34. You have been given a basic medium, and in alcoholic basic medium you will have a acidic hydrogen which is coming out. Acidic hydrogen would be the immediate hydrogen next to the electron withdrawing group, which is this. This is your minus M minus I group. So this carbon's hydrogen will be acting as an acidic hydrogen. We have learned this in many other areas also. So this H will be taken out by alcoholic KOH. So it will form the carboanion. Now this carbanion can do the internal attack onto this carbon where the chlorine is present, forming this cyclic shape, and chlorine will be removed as the leaving group. So Cl minus will be out. H plus, which has come out due to the base, will combine with chlorine to form HCl and will get released. So this is the product which will be formed, which is your option number C. Now in question number 36, they are asking rank the acid derivatives with respect to their reactivity with water. First of all, we need to understand reactivity with water depends upon, because it's a nucleophilic addition, it depends upon the delta positive of carbon of C double bond O. We have to see how stronger the delta positive is. Now let's talk about the acetaldehydes first. In acetaldehydes, minus I group is present over there, so delta positive will be definitely higher. In case of anhydrides, there is a plus M and minus I group. Okay, but plus M is also not very strong because it is getting distributed. This is showing plus M here as well as here. So plus M is quite weak. Now come to this, here you have ether group. This is your overall ester, but this O group is purely plus M. It is donating electron density and minus I obviously. So plus M, where there is no division of the charge, it is not going anywhere else, it is just moving towards the carbon. So if you compare anhydride and ester, anhydride has weaker plus M and has stronger delta plus. Now come to CONH2. Even in case of NH2, it is a donation capability, but nitrogen has less electronegativity as compared to oxygen. So donation is better. So donation here is better, and that's why the delta positive is further weaker in case of NH2. If you compare ester and amide group, in case of ester, the donating group is oxygen. Here it is amide. Oxygen will donate relatively lesser as compared to nitrogen. So all groups are plus M and minus I, but donation will be weaker in case of NH2, and that is the reason why the order is acid halide, then anhydride, then ester, and then your amides. Now come to question number 37. In question number 37, number of functional groups which can be reduced by NABH4 and LiLH4 is what we have to identify. There are three functional groups given. One is ketone, one is aldehyde, one is ester. NABH4 can reduce only aldehyde and ketone to respective alcohols, whereas LiLH4 can reduce aldehyde, ketone, and ester, all the three, to their respective alcohols. Hence, NaBH4 can reduce 2 and LiLH4 can reduce 3. So option is B. That is 2, 3. Similar type of question is there in question number 38 also. In question number 38, again, we have been asked number of functional groups that are reduced by LiLH4 and NaBH4. Three functional groups are given. One is aldehyde, one is ketone, and third is nitro. Again, our LiLH4 can reduce CH2 to respective alcohol, ketone to respective alcohol, and nitro to amine. Okay, and NO2 to NH2, that is reduction of nitro to amine. So basically LiLH4 can reduce 3 compounds, whereas NaBH4 can reduce only 2, aldehyde and ketone. So option is, again, your answer is 3, 2, LiLH4 3 and NaBH4 2. This is your option number C. Now come to question number 39. In question number 39, they're asking which of the following reaction is not reduction. Reaction 1 is reaction with hydrogen of acetaldehydes, obviously reduction. Option 2 has bromine with CCl4, which is the addition of bromine to both the positions. Addition of electronegative atom is called oxidation, not reduction. So this is not a reduction reaction. Third reaction what is given is the reaction of ketone with hydrazine. Again, it is reduction. And NaBH4 reduction, which is the fourth one. Ketone reduction with NaBH4, that is also reduction. So only one option is correct, that is B. Come to the question number 40. In question number 40, they are asking about which of the following is enamine. First of all, you need to understand what is enamine group. Enamine group is where you have a double bonded carbon and attached to it is your nitrogen with any type of amine, primary, secondary or tertiary. Any kind of amine can be present over there. So this kind of group is called as enamine group. Here you can have H, you can have R, you can have anything. So if you understand this is enamine, then you can just check in the options. This is the option given where you have a carbon with a double bond and nitrogen present with 2 R groups. This is your enamine. It is not necessary to have R groups. You can have the hydrogens also present over here. This is your enamine group. So this is your option number 2, B.